Ask My Instructor 4.2.48. Use the second derivative of the function to determine the intervals on which the function is concave up or concave down. Identify any inflection points. First, find the derivative of the function. After you find the derivative of the function, you need to find the second derivative. Once you have the second derivative, you find all possible inflection points by setting the second derivative equal to 0 and solving for x. Setting y double prime equal to 0, I see that y double prime is going to be equal to 0 when force sine of 2x equals 0, which means that sine of 2x has to be 0. So, where is the sine function equal to 0? For that, let's go to the unit circle. It is easy to see that sine is equal to 0 at angles 0, pi, and 2 pi. But you know, I could keep going around the circle and get 3 pi, 4 pi, 5 pi, and so on. And I don't have to go in a positive direction. I could go in a negative direction. Since sine is equal to 0 at 0 plus or minus pi, plus or minus 2 pi, and so on, y double prime will equal 0 when 2x takes on those angle values. Now, if 2x is equal to 0 plus or minus pi plus or minus 2 pi, then x is equal to 0 plus or minus pi over 2 plus or minus pi plus or minus 3 pi, and so on. Which of these values of x are in the given interval? See if you can sketch that out and find out which of them are in the given interval. In my sketch, you can see that negative pi over 2, 0, and pi over 2 are the points that are in the given interval. And so those are the possible inflection points we are interested in. We use those values to divide the interval into subintervals. And then use test points to find the sign of y double prime in each subinterval. For the first subinterval, I could choose negative 7 pi over 12. Well, if I do that, then I run into a little bit of a glitch. I need to figure out what 4 times sine of negative 7 pi over 6 is. For that, I'm going to go to the unit circle. If I were to go in a negative direction, 7 pi over 6, that would put me in the same location if I had instead gone in a positive direction of 5 pi over 6. So the sign is the same, whether I'm doing negative 7 pi over 6 or 5 pi over 6. The sine function has the same value of 1/2. Multiply that by 4 and I get 2. For my first test point, y double prime is equal to 2, and that value is positive. Doing this for each subinterval, we get the sign of y double prime for each subinterval. If y double prime is positive, the function is concave up. If y double prime is negative, the function is concave down. If a function goes from concave up to concave down, that's an inflection point. If a function goes from concave down to concave up, then at the point where it switches, that also is an inflection point. So by now you can see we have 3 inflection points. So in my first subinterval, my function is concave up, then there's an inflection point, and then concave down, and then another inflection point and concave up, another inflection point and concave down. Let's look at the graph of that. Concave up, inflection point, concave down, inflection point, concave up, inflection point, concave down. Have a great day, and let me know if you have any questions.